Relations of functions. When you're dealing with these, today our goal is to figure out what domain range and how relations become functions and what makes a relation a function and what makes a function or what makes a relation not a function. All right? Those are the vocab terms you need to write down. So those four terms I want you to put into your notes. You give yourself a write relation and then give yourself a couple lines and then write domain, give yourself a couple lines. That way you know what you're defining today as we go through these. You give yourself some space to define them. All right, I want you to right now tell your neighbor everything you know about those four terms. And some you won't know anything about, but some you've heard before. Take a guess. If you don't quite recall, take a guess.
I feel like I know it.
Okay, what's a relation? What's a domain?
Wait, I have a question.
Yeah, what's relation?
It's like the bond between two or more things.
Okay. Mathematically, there's a bond between these two
I
things.
think relationships.
Okay. How about domain? How about range? Yeah?
The lowest number and the highest number, between those two.
Good. So yeah, in range we think of what's the highest and what's the lowest, and we find the difference between the two. Now when we're dealing with relations of functions, it's a different range than that. So, but yeah, that's the range we usually have heard of. Yep.
Is it the, like, I think it's either domain or range. It's like y is greater than or less than, and then
Yeah, that actually is how we'll express the domain and range. Yeah. Yeah, range goes with y, domain goes with x. We'll talk about that here in a minute. What's function? Okay, so there's a lot we need to pick up today. You know what a function is?
Can I explain it when it's on a table or a graph?
Yeah, go ahead.
So a function on a graph is where you have different points on your graph and a line goes through one point. But if the line goes through 2 points, it's a relation. And on a table, a function is where in the x column example you would have like 1, 2, 3. As long as the numbers aren't repeating themselves, then it's a function. But if they are, then it's a relation. Like if you have 1, 1, 2, then it's a relation.
Good. That's right. We're going to show that today. So you've covered some of that. That's good. All right. Relationships can be represented by a set of ordered pairs called a relation. So really, all a relation is a set of ordered pairs when we're dealing mathematically. Now, don't tune out right now. There's a lot of vocab that we're going to deal with first. Okay. So if you can bear with us through the vocab, it'll be a lot easier. So you need to know these terms. You guys didn't know them a second ago. Most of you. Some of you did.
I kind of do the same.
Okay. Now I will be writing on this cool board every once in a while. Okay, so if it's turned on, that way it actually writes on. So my arrow moving around there. There we go. Okay. So whenever I'm dealing with, say, like an x and y value, that is an ordered pair. That's a relation. Now that little mark isn't supposed to be there. I couldn't see that. Have you guys seen this board before? Have we used this in here?
No.
Oh, cool. We just got it last week. It's kind of tough to write on. You guys will write on it eventually. I'll just pass it out to you. You'll write on it. Pretty cool. Yeah, you can draw all kinds of pictures like stars and happy faces. And I'd draw a butterfly, but I'm not good at it.
Is this on the video right now?
Huh? Yeah, it's recording. But. So any x, y value is a relation. Okay? That's simple. Any questions there? All right, next one. I want you to go ahead and express these three relations, these three ordered pairs, the 2, 3, the 4, 7, 6, 8. Put it in a table, make it into a graph, and make it into a mapping diagram. Now, mapping diagram, you may not know what that means, but I'll explain it here in a minute. But at least get them into a table and a graph. And on the graph, you can just sketch a quick graph on your paper. Okay, give yourselves a couple minutes to do that there. See how you guys match up.
So math.
No, we'll see it here in a minute. You're tall. Hey, let's see how yours matched up. Here's my table. Got my x's, got my y's. No problem with table?
Did it.
Most of you seem to have it. How about your graph? Plotted our ordered pairs?
Exactly.
Yeah? How many of you connected the points? Okay? And one thing that we want to recognize is that when we're dealing with, say, a lot of times figure out, okay. When we're dealing with, this is called discrete data. When I'm just given ordered pairs, if it's not an equation, usually our data is discrete. So that means we're just plotting these points. That means the stuff in between, which would be represented by a line, that stuff, that was very tough for me to draw. Okay? That stuff we don't show. All right? So right now we're just dealing with discrete data. So we just have these points. If you put a line in between, just make a note of it. It's called discrete. If it has a line in between, it's called continuous. The points just go on. You could have a 2.5. You could have a 3.5. You could have a 5.5. Here we don't know if we have those because they just give us these coordinates. Okay? All right. Mapping diagram. Let's see if we can do a mapping diagram. Here is the description of a mapping diagram. Based on that description, I want you to write down your mapping diagram, which means you're going to have to take a step of faith to see if you can do it based on descriptions. Okay. Refuse to try saddens me. Here we go. Now I saw a bunch of you draw all of that stuff in there with the exception of the little boxes around the X's and Y's. That's good. So go ahead and box them if you haven't done that. Put your little bubble around them. But all you're doing is you're listing all your X values in one box, all your Y values in another, and you're showing how they correspond. Okay, 2 goes to 3, 4 goes to 7, 6 goes to 8. Okay? Now if I was to add one more coordinate here, say the coordinate 2, I don't know, 15, thank you, 215, thank you for helping me decide. So we put one more value here. All right. That would now mean from my 2, I would be going to one more point, which would be 15. So I'm going to write 15 down here. If I could actually write 15, there we go. And from 2, I would have another arrow going all the way down here to 15. You'll notice now from this X value up here, that 2, I no longer have only one coordinate, or one point. I have, sorry, I got to find my arrow. I have 2 things coming from 2. Okay? I want everyone to add 215 to their graph. Actually, is that too big of a point? Let's change that point. Let's make it 25. Okay? Let's make it 25. That way it's easier to add to your graph. Go ahead and add 25 to your graph. Okay, so if I put 25 on my graph, I'm right here. Now based on Kara's description earlier, first, before we had this point right here, when we didn't have 25 there, this is a function. Because if I look at my X values, this one, this one, this one, notice these vertical lines that are going up and down. Each time I draw a vertical line up and down my X-axis, or my X value, excuse me, it only can hit a single point at a time. Everyone see that?
Yeah.
It's called the vertical line test. When I'm drawing these vertical lines, if it'll only hit one point as I draw a vertical line, then it's called a function. Now when I add the 0.25 in, notice that vertical line I drew right there now hits 2 points at a time. Okay? When I add the 0.25 in, this no longer passes the vertical line test. So without the 2.5, I'm good. It's a function. With the 2.5, I'm not good. It's not a function because it doesn't pass the vertical line test. Okay, so everyone explain to your neighbor what a vertical line test is. And freaking out and whining, stop whining. You'll be okay. There are about 4 of you. A couple of you said something to me. Relax, it'll be okay. Okay, So, explain to me the vertical line test. Go ahead.
If so you like draw vertical lines up the graph.
Okay.
And, if one vertical line hits more than one dot, one point on the graph, then it is not.
Perfect. Yeah. You draw vertical lines up the graph. Or maybe you use your pen, you lie your pencil across the graph and you move it across the page. If your vertical line hits more than one point at a time, then it's not a function. If it only hits one point at a time, then it is a function. So that's our test, whether or not a relation's a function. Danny?
Why couldn't you just use the lines that are already there, though? Why did you not do that?
You don't have to draw new ones. You could use the vertical lines that are already. Okay?
It's just not work.
All right. All right. Hey, one other question before we start looking at that. We had, let me get it back here. Jacob said, hey, wouldn't you put the 5, like, doesn't the 5 need to go up here? Okay, and the answer is, yeah, you can put the, what in the world? Did I go backwards here? All right. Oops. Sorry. So we got to get the 5. Jacob was asking if we put the 5 in the correct spot. I can't find my arrow again.
So it has to be in alphabetical or numerical order.
You usually put them in numerical order. You wouldn't have missed it by doing that, but that's a good question. You guys don't know that. So to make it easier on yourself, yeah, you usually put the 5 there. Okay, now remember, we had originally put 15, so maybe that's why we didn't do that. Okay, we also can tell that this isn't a function just because this 2 right here maps to 2 different things. It goes to 3 and to 5. That's how that that's how the mapping diagram helps you out as well. Okay, I want you to take a look at your assignment. Okay, go ahead and look at the top page there. And I want you to read the top to yourself there. So really the top is just kind of going through what we've already went through, right? With the exception of how to list domain and range. I'm going to go through that with you right now. Okay? But I want you to do 1, 3, and 5 on your own right now. Okay? So off this bottom part, work on 1, 3, and 5 on your own. You can even work with it with your groupies actually if you want on it. Okay, this is asking for domain and range. Remember our definition of domain? Domain stands for what value?
The X value.
Domain is your X. Range is your? That's your Y. Alphabetically, D comes before R. X comes before Y. So you can think of it that way as well. But anytime you're dealing with graphing, you usually refer to domain as X, range as Y. Domain and range. Okay? All right, so Kara's going to show number 1. Explain what you did there, Kara.
So I took all the X, since X is the domain, I did all the numbers in the X bar in the D category. And for range, since that's all Y, I did all the Y numbers, but since there's 2 4s and you can't repeat a number, I just put it in once.
Good. Everyone see that? She didn't repeat that 4 because it's there. It appears twice. Nice work. Now, notice, can I write on here?
Yeah.
Notice that on Kara, she also put parentheses around them. Usually we'll do these cool brackets. They look like this. You put a parenthesis with an arrow and a parenthesis. Some people just squiggle that. That's called set notation. So we'd write it in like that. Kara, very good job. Nice work. Who's going to do the next one? Number 2? Slow down, not everyone at once. Yes. All right. Logan's got number 2. He's going to bring it up. Is there? Explain that if you need help. Make sure you're asking. All right. So Logan, what do you got?
For the domain, I just listed all the X values. And for the range, I listed all the Y values. And
Yeah, and increasing numerical order is fine. They've got them in order right there based upon the order which they're given. That's perfect. Very good. Nice job. Anyone get number 3? Danny, you want to try it? Number 3 is tough, man. We haven't talked about one like that yet.
I'm a little nervous.
Oh, you should be.
I don't think you should be.
Is it? I don't like this. Last time I had trouble with this too. Okay.
It's all right, Danny.
Fail.
Let's do this, though.
What?
Are you doing? Oh. We want to do number 5, Emma.
You said number 3.
I did. We just did number 3.
Man, we just did number 2.
No, we didn't. We did number 5 or number 3.
No, we didn't.
We did number 2.
We did number 3.
We did number
Yes,
three.
he said 1, 3, and 5.
I'm sorry. I said 1, 3, and 5, and we just did number 2. I'm sorry, Danny. But your number 3 looks amazing. Well done.
I'm so done.
What?
What do you mean what? Logan just explained number
No,
3.
he explained number 2.
I swear
I'm-
we did number 2.
Well, first we don't need to swear. That's unacceptable.
No,
Okay.
he did number 2.
He did this one. Logan, did you do this one? Am I living? I just want to make sure I'm not in a parallel universe. He did this one.
We did a
Hold on, we have it on video. We will record. We're recording, so we can rewind the tape. It'd be like instant replay, NFL style.
Wait, that just happened? Like I was in that? Yeah.
All right, here we go. Let's talk about on a graph. So focus up here. This is right back here. This is where it gets a little confusing. Okay, so when we're dealing with X and we're dealing with the graph, you'll notice their domain and range for the graph looks really kind of weird there.
Yeah.
Okay? What they're really doing is they're telling you where this graph starts. Now they've put in the dashed lines. Okay? Help Anderson stay awake. He really needs some coffee or something. Okay?
Can I throw something at him?
No, don't throw it. That's not how we want to stay awake. Sam, just, bump him everywhere. Okay? I tell Abby to do that, but she might really slug him. All right.
I only hit 2.
So we are going to say, where does this graph start on the x-axis?
-2.
Okay. Everyone tell your neighbor where it ends on the x-axis. Quietly tell them.
2.
Good. So on the x-axis, this is how you write these. You write x. This is your domain. So for those of you like, I don't know how to write that, and that's where this is where most students struggle. They write x because that stands for domain. Their first value they write is where you start. The value you write on the other side is where you end, where your graph ends. Okay? Oh, there he goes. Stay away. I'm going to have you come up here and teach. Okay? We start at -2. Anderson, where do we end? We end at 2. Okay? Everyone see that? Starts at -2, ends at 2. Notice at the ends there aren't open circles. They're not closed dots either. But if there aren't open circles, that means it could be equal to that value. So what we've got is we've got our start and we've got our end. Now some of you really struggle with the compound form. So rather than putting 2 inequality symbols in here like this, we're going to write it the other way. We're going to say in relation to the -2, x has to be, does it have to be greater than or lesser than?
Greater than.
So are we getting smaller from -2 or getting bigger? Bigger. So x has to be greater than or equal to -2. In terms of the 2, if we're at 2, are we getting bigger on the x or less?
Less.
We're getting less. So x has to be less than or equal to 2. So notice these arrows now. The reason I wrote it like this is because then it makes writing it like this easier. This arrow is pointing at the -2. So my arrow has to point at the -2. This arrow is pointing at the x. That is my domain. Okay, is it weird?
Yep.
It's a different notation. It's a little tougher. You studied it just last chapter, but I want you to write the range doing the same way. Okay? Everyone try the range on your own right now. Yeah, it doesn't. All right, let's check it out. So range deals with what variable, x or y? Y. So once again, we want our start and we want our end, our finish. Okay, where do we start on y? So going up the graph.
-1.
Start right here at 1. Where do we end? We end at 4. Okay, so I have y, I have 1, I have y, I have 4. So from 1, am I getting bigger or smaller? Bigger. So that's a greater than. Could it be equal to 1? Can our graph hit that point? Yeah, it's not an open circle on your graph. If you don't see an open circle, then it can be that. So we have the equal to piece. At 4, are we getting bigger or smaller? Smaller. So it's lesser than. Okay, so the y and the 1, it's pointing at the 1. The y and the 4, it's pointing at the y. There we got it. How many got it right? Good. Any questions on them? Sam?
Number 6.
Why should I do number 6?
Slightly different.
It is a little different, but I think you guys can do it. You still ask?
There's no line.
Well, it's still a shape, right? Where do you start on x? -3. Where do you end on x? 2. Where do you start on y? 1. Where do you end? 3. Okay? Doesn't matter what it is, still have the domain and range. Okay? All right.
Is this whole packet for the band?
I want you to turn the page. Yeah, but you're going to finish those other 3 as part of your assignment today. Next part. We talked about this a bit, about functions. A function is a type of relation where the x value or the domain can be paired with one y value or the range. Okay? So here's our function. We've got it in table form. We've got it in graphic form. And then, unfortunately, they didn't put these in the mapping form. So why don't we cross out this mapping diagram? Because that's an ugly one because it doesn't match up anything. Why don't you draw a new mapping diagram for that right now? Okay, with your x's and your y's, based on these x's and y's up here. Now, do we have to list 4 and the y one twice?
No.
No. All right, that's a better mapping diagram. Hey, is this a function? Remember, a function is a type of relation where each x value can be paired with only one y value.
No.
So does each x have only one y? 2 has 3, right? 3 has 4. 4 has 4. 5 has 6. So each of these x's only gets one y. It just so happens that these are the same 2. When you have a picture, does it pass the vertical line test?
No. Yes.
Does it pass our vertical line?
Yeah.
Yeah, it does. Okay, Josh, I need you to pay attention, though. Okay, you're looking down. All right, how about on this one, though?
Nope.
5, 1, 6, 2, 6, 3, 7, 4. Tell your neighbor why this is not a function. All right, I'm going to cover that bottom part up because it doesn't go with this again, but hey, what are the problems? Danny?
The x value has 2 sixes, and you can't have 2 of the same x values.
You can't have 2 of the same x values. Anytime you have 2 of the same x values and they're paired with different y's, then it's not a function. And when you look at this right here, that problem gives us where it hits the vertical line twice. Okay, versus on this one where we had them paired with different x's paired with the same y, you get this type of line, and that's okay. When you get this line where it hits on the same vertical line, it doesn't pass that vertical line test, so not a function. Okay, I want you to try number 7 and number 9. Number 7 and 9. Tell whether relation's a function and explain your reasoning there, please. Actually, why don't we do 7, 8, and 9? Those 3. That way we don't confuse Danny or Abby this time. It's all right. So Danny's she's going to do number 7. Yep, then Abby, you can do number 8 if you want. All right.
Wait.
Just set it
Okay, it's kind of more of a like broad answer. But
Here, we'll cover it up like that.
Not okay.
There we go.
You want to read it to us?
oh,
English.
well, people can read, but no, because x can't be the same value twice. But to be more specific, -3 is there twice, and so that would be like is it vertical?
Yep.
Vertical line would have 2 dots on it, and you can't have 2 dots because that's a rule.
Can't have 2 dots in the same vertical, so -3 would have 2 and 3. Good.
What a rubber.
All right. Can't have the same x value appear twice and go to different y's. Abby's got number 8. Who's going to do number 9? I think number 9 is the easiest description.
Okay. Whoa.
Whoa. Number 8.
Okay, number 8 is a function because even though 4 and 8 share 5, it will still pass the vertical line test because they have different x.
Okay.
values.
So really, we don't want to start referencing the vertical line test all the time. She's definitely right. It will pass the vertical line test, and it is a function. But more specifically, talk about the x values going to having only one y value, mapping to only one y value. Okay?
Okay.
So number 8, each x goes to its own y. Who wants 9? Number 9, everyone, both people have. All right. Number 9, both of you reference why it is or is not a function. Who says it is a function? Who says it's not a function? Why is it not a function?
Because 3.
Nathan?
Because there's 2 for the 4 and the 2.
Yeah. There's multiple points. Like if I draw my vertical line here, it hits in multiple points. In fact, I actually could, if I had a paper clip, which I don't. Those are all binder clips. But if I were to pick and do a vertical line test right here, each of these points, if I slide my paper across it, it hits in multiple areas many different times. It doesn't pass the vertical line test. Yeah, so not a function.
Why not?
Doesn't pass the vertical line
I
test.
thought we couldn't reference that.
Yep. You can if it's a graph. You can reference the vertical line test on a graph. If you're going to use the vertical line test as your reason here for number 7, you need to graph those points so we can see that it doesn't pass. Otherwise, you just say, like Danny did, each x goes to, or -3 repeats and it goes to different y's. -3 goes to 2 y values. Okay, so you finished that page. Your assignment today, you need to finish that first page as well as the 6 on this page. Come on. So you're going to finish the packet, in other words. There's 6 there. I'm just trying to point out how many there are so you're not freaking out. There's 6. And then there's like a couple on the next page, like 6. And then there's like 5. And then the back page is easy. What's another name for x that you came up with today? Tell your neighbor. What is it, Ricardo? It is domain. What's another name for y that you came up with today? Everyone write it down.
Range.
Yeah, way to yell, Josh. Okay. Did you write it down? What is it?
Range.
Range. Good. Okay. Can we think of other names for x besides domain? How about this one? I didn't reference it today. Holy moly, if I could write. Independent. Independent. Which means y is our? Dependent. Y is our dependent. These are all different names, just like slope had a bunch of names, or will have a bunch of names when we talk about it. And rate, okay, domain, range, independent, dependent. How about input?
Output.
X is our input. Y is our
Output.
output.
Oh yeah, we read the speeches when we learned about that in second grade.
There you go, man. All right. Now you're done with the back one. When we come up with another one, we'll add it. All right. That's it for now.